So a lot of people are asking questions about the titration lab, the weak acid, strong base titration. So weak acid and strong base is NaOH. So I'm just gonna walk through those things. Let's say I have the titration curve and I have some numbers where it's 22 milliliters to start, because we know that the burettes, are tall. People can't often start at 0 milliliters because it's super high up on the burette. And if you have to start at a different number, which is 22 in this case, and we drop in up to 74.5 milliliters, those, that might change how you calculate things. So the first part is determine the molarity of the acid. Well, we know molarity of acid, this is how you do this. So remember, at the equivalence point, this is the equivalence point here. When it's done, moles of acid equal moles of base. Okay, so how do I get moles of base? Well, I know the molarity of the base. I know the volume of the base, which is this value here. But it's not 74.5, it's the difference between these two things. So if I take 74.5 minus 22, and that gives me 52.5 milliliters. Okay, so that's my milliliters of NaOH. Well, to get moles of base, remember molarity times liters equals moles. So 0.10 molar is my molarity of the acid, a base, times this in milliliters, 0.0525. That gives me 0.00525 moles of NaOH, which equals moles of acid. So in this case, molarity of the acid is moles over liters. So my moles of acid would be 0.00525 divided by the volume, which is 20 milliliters. Okay, that's how much acid I titrated, and that gives me, in this case, it would give me 0.00525 divided by 0.2625 molar. Okay, so this is not going to be what yours is going to get, but in this case, let's say I have a 0.2625 molar. Okay, so now the next part is using the concentration. This is my molarity of acid. So this number here, using this number, can I get the Ka of the acid from the starting pH? So remember, this is the starting pH. And the acid is just chilling there. It's just an acid. It's sitting there. Nothing's been titrated. I have just acid in here, HA, okay? So my 0.2625 molar acid at this point here, how do I get the Ka? From this pH. So let's say my pH, I'm just gonna make up a number here. So let's say my pH is 2.91 pH. Okay, so how do I do that? So let's take this information. So my starting pH is 2.91. My molarity is 0.2625 molar. And so if I want to figure out the Ka, remember Ka is H plus times A negative all over HA. Okay, and if I set up a Rice chart how we've done, so if I have HA goes to H plus A negative, and I have my concentration here. So this is 0.2625, 0 and 0, and minus X plus X plus X, all that stuff. Then I can see that, oh, this is X times X all over 0.2625 minus X, which is X squared over 0.2625 minus X. Well, how do I get Ka? Well, how do I get X? X is H plus. And if I have the pH, I can get the H plus. So remember, pH equals negative log of H plus, or H plus equals 10 to the negative pH. So I can take this here and 10 to the negative 2.91, and that gives me, in this case here is, 10 to the negative 2.91, that would be 0.00123, and then I would take this number and I would plug it into here, and I'll plug it into here, and Ka would equal some number. Okay, so that's how you get the Ka value from a starting pH and a starting molarity. For question 3 asks, from the half equivalence point, so question 3 says, determine the half equivalence point, and then what's the Ka from the half equivalence point? So the half equivalence point is going to be halfway, right? And so some people are wondering, well, how do I get the half equivalence point if I don't start at 0? Well, this difference here, that, remember, is 52 milliliters, 52.5 milliliters. So 52.5 milliliters. Well, halfway is half of this number. So the total volume to the half equivalence point is 52.5 milliliters divided by 2. So 52.5 divided by 2 is 26.25 milliliters. Well, that's not 26.25 is going to be around here, right? But remember, I got to add this on to 22. So you take 22 and you add 26.25 because it's halfway from this point. And so that's going to be about, so you add 22. So that'll be 48.25. So 48.25 would be right around here, halfway. So that's 48.25. So on your graph, you estimate it and you go up. Sorry, I drew this wrong, but right here would be your half equivalence point. And that's pH right there. Remember, the pH equals pKa at the half equivalence point, and only at the half equivalence point. So if my pH, let's say it's 5.2, okay? So I just made up a number, but let's say my half equivalence point pH is 5.2. Well, how do I do that? So I go to my sheet here. I would write at the half equivalence point, pH equals pKa, which equals 5.2. Well, if I want to get the Ka by itself, Ka equals 10 to the negative pKa. So if I want to change it back to Ka, so I would just take 10 to the negative 5.2. In this case, 10 to the negative 5.2, and that would be 6.31 times 10 to the negative 6. Okay, and so that's how you get your Ka from the half equivalence point.